Just recently, a tropical cyclone gained incredible strength, leaving scientists absolutely stunned and scared. Within 72 hours, this disturbance became a high-velocity monster, locking its sights on even rarely hit districts.
The family locked the door and closed all the windows and ran.
I'm sad. The damage you see outside is what you see inside. I don't know how we are ever going to live in this house again.
On January 28th, the atmosphere over the Mozambique Channel began to shift in a way that defied standard seasonal patterns. This wasn't a typical tropical disturbance. The system, named Tropical Cyclone Fytia, began a rapid intensification as it tracked eastward toward Madagascar. Satellite data showed a tightening core and a sharp drop in central pressure, signaling a massive surge in strength before it even neared the coastline. The warm waters of the channel acted like high-octane fuel, providing a constant energy source that turned a developing storm into a major threat in less than 72 hours. Meteorologists watching the real-time feeds saw the eye wall structure organize with startling efficiency. Usually, these systems take time to consolidate, but Fytia's central convection exploded upward, punching into the higher altitudes of the troposphere. This rapid deepening meant the wind speeds were climbing much faster than early computer models had predicted. By the time the storm was halfway across the channel, the infrared imagery showed a distinct, clear eye, the hallmark of a mature and dangerous cyclone.
Oui, le bilan continue de s'alourdir à Madagascar à la suite du passage du cyclone Fytia. 9 personnes sont mortes, 64 000 personnes sont sinistrées.
What made this intensification so specific was the lack of vertical wind shear. Normally, high-altitude winds would tilt a storm or blow it apart. But here, the conditions were eerily calm, allowing Fytia to build into a perfect, symmetrical engine of destruction. As the pressure continued to plummet, the forward speed of the storm increased, locking it onto a collision course with the western shores of Madagascar. Agencies began scrambling to update their warnings, but the sheer speed of the storm's evolution meant the window for preparation was closing faster than anyone on the ground could have anticipated. This was no longer just a weather event. It was a physical force gathering enough momentum to reshape the landscape it was about to encounter. But as the winds reached their peak, the storm aimed for a region where help couldn't easily follow.
We're expecting an additional 400 millimeters for one or two areas near where the storm is making landfall.
By January 31st, the cyclone made its definitive move toward the western coast of Madagascar. This wasn't a hit on a major urban center or a developed port. Instead, it was a direct strike on the Malaki region, specifically the districts of Mitsinju and Soalala. These areas represent some of the most remote geography in the country, places that are rarely the focal point of international humanitarian crises due to their extreme isolation. As Fytia crossed the coastline, it brought a combination of heavy rainfall and a dangerous storm surge that pushed deep into the low-lying western plains. The geography of Malaki is defined by vast, flat marshlands and intricate river networks that provide almost no resistance to incoming seawater. When the surge hit, it didn't just flood the beaches, it moved miles inland, turning dry trails into impassable waterways. In Mitsinju, the wind speeds were high enough to strip the thatched roofing from traditional homes in seconds. The storm wasn't just passing through, it was hovering over a landscape that had no natural or man-made defenses against this level of hydraulic pressure.
Resources are stretched. Supplies are running low.
Whenever we receive donations, we give people food.
Local reports from the early hours of landfall described a sky that had turned a bruised purple, followed by a wall of rain so dense it reduced visibility to a few meters. For the people living in these remote coastal villages, the primary concern wasn't just the wind, it was the rising water. The drainage systems in these districts are non-existent, and the soil quickly reached a saturation point, leading to flash floods that cut off the few dirt tracks connecting these communities to the outside world. By midday on the 31st, the physical landscape of Soalala had been fundamentally altered by the surge, leaving thousands of residents trapped between the advancing sea and the flooded interior. As the last radio towers flickered out, a wall of silence began to descend over the region.
Disparu, emporté par une rivière à Majinga. Les dégâts matériels sont également considérables. 11 000 habitations inondées, 2 000 cases détruites, des arbres déracinés, des toits arrachés, des écoles entièrement détruites.
As the storm moved further inland on the night of January 31st, the flow of data stopped entirely. This created a significant black hole for both meteorological and humanitarian authorities trying to track the fallout. Because the hit occurred in such isolated districts, physical access was immediately severed by the combined force of the weather and the difficult terrain. While forecasts continued to warn of extreme wind damage and flooding across central and northern Madagascar, the actual human cost in the impact zone remained a complete mystery. It was a period defined by what experts didn't know as the storm continued to batter the interior. This information vacuum meant that for nearly 24 hours, the BNGRC and its international partners were flying blind. They could see the storm's position on a satellite map, but they had no way of knowing how many homes had collapsed or how many families were stranded on rooftops. The communication infrastructure in Malaki, already sparse to begin with, was effectively leveled. Cell towers were either knocked down by the wind or ran out of battery as power grids failed. The lack of ground truth data is the nightmare scenario for disaster response. Without knowing which villages were hit hardest, relief flights couldn't be prioritized, and search and rescue teams couldn't be deployed. The storm's path through the northern highlands only compounded the issue, as heavy rains triggered mudslides that blocked the few remaining mountain passes. For the people in the unreachable districts of Mitsinju and Soalala, the world had effectively shrunk to their immediate surroundings. While the rest of the country watched the weather charts, the survivors were navigating a new flooded reality with no way to call for help. The crisis was happening in real time, but for the outside world, the screen had gone completely dark. However, once the clouds finally cleared, the first images of the broken schools told a heartbreaking story. When the first reports finally trickled out from humanitarian partners, the damage to the educational sector was the most visible indicator of the storm's power. Across the region, 22 schools reported significant structural damage, with 8 of them confirmed as completely destroyed. This wasn't just a loss of property. It was a sudden, localized collapse of the future for an estimated 1,100 students. In many of these remote villages, the school is the only reinforced structure in miles, so when they fell, the community's primary sense of safety fell with them. The destruction of these buildings means that even after the water recedes, the rhythm of daily life cannot simply return to normal.
Channel is passing extremely close to the coast of Mozambique, less than 100 kilometers offshore and moving south. It is so close that small changes in track could greatly influence the severity of local impacts over the coming hours. But
the crisis then began to ripple outward into the more populated urban centers. To handle the immediate fallout, surviving schools in Mahajanga, Maruvwe, Ambuhidratrimu, and Atanana Rivu Atsimundranu had to be completely repurposed. Almost overnight, these places of learning shifted into temporary accommodation sites for the displaced. Desks were pushed aside to make room for sleeping mats, and blackboards became the backdrops for emergency logistics charts. While this transition provided a roof for thousands, it effectively halted the education system across central and northern Madagascar.
Many homes were damaged or destroyed, forcing families to seek shelter. Authorities say schools were shut and emergency shelters were opened ahead of the cyclone, but the storm still caused extensive damage when it hit.
The infrastructure failure wasn't limited to rooftops. The heavy rainfall caused localized sewage overflows and compromised the few clean water sources available in the remote west. In the districts where the schools were leveled, the debris itself became a hazard, blocking drainage paths and turning playgrounds into stagnant pools of runoff. This structural toll created a secondary crisis: how to house a growing number of displaced families without permanently sacrificing the school year. The authorities were forced into a difficult balancing act, trying to provide basic human dignity in classrooms that were never designed to serve as long-term shelters. But even as shelters filled up, the true scale of the human exodus remained hidden behind the mud. The initial tally for the disaster was grim. An estimated 5,000 people were confirmed displaced in the immediate aftermath. However, the true total for Mitsinju and Soalala remained unestablished for days because the districts were effectively unreachable by road or air. The cyclone didn't just cause temporary chaos, it created a logistical nightmare in a region where help is always days away under the best conditions. With roads washed out and the soil turned into a thick, impassable slurry, the recovery effort was stalled at the very moment it was most critical. In these unreachable districts, the displacement was likely much higher than the early numbers suggested. Families who lost their homes were forced to move into the highlands or huddle in makeshift camps on whatever dry ground they could find. Because Fytia hit areas that are rarely the center of humanitarian aid, there were no pre-positioned supplies. No stacks of clean water, no emergency medical kits, and no easy way to get them there. Relief teams in the capital could only watch the satellite maps, knowing that the people in Malaki were essentially on their own as the floodwaters continued to rise. Even as the winds finally died down and the eye of the storm dissipated over the interior, the danger was far from over. The risk of massive flooding in the northern lowlands remained the primary concern for the authorities on the ground. The saturated earth simply couldn't hold any more water, and every additional millimeter of rain threatened to burst riverbanks already pushed to their limits. This long-tail recovery means that for the people of Mitsinju and Soalala, the end of the storm was only the beginning of a months-long struggle to rebuild a life from the wreckage of the Western Plains. While the world watches the sky, the real battle for survival is quietly being fought in the mud. With the schools leveled and the roads gone, how long will these remote communities have to wait before they are no longer unreachable? Let us know what you think in the comments.